Hello students, I'm Professor Priya. Today we're exploring the fascinating chemistry behind brewing tea, from the compounds extracted to the perfect cup of chai.
Professor, I drink tea every day, but what actually makes it taste so different from just hot water? There must be some chemistry happening.
Excellent question, Sneha. When hot water meets tea leaves, it extracts various chemical compounds. Let me show you what's happening at the molecular level. As we add hot water to tea leaves, watch how different compounds start dissolving. The color changes as polyphenols and tannins are extracted.
Wow, I can see the water changing color from clear to golden brown. What specific compounds are responsible for this beautiful color?
Great observation, Arjun. The color comes from polyphenols, especially tannins. These compounds also give tea its slightly astringent, dry taste. Along with tannins, caffeine is also extracted. This gives tea its stimulating effect and adds a bitter note to the flavor profile.
I notice black tea has such a rich, deep color compared to green tea. Are different compounds responsible for this?
Excellent question. Black tea contains theaflavavins and thearubigens, special compounds formed during fermentation that give it that distinctive golden brown color. Now watch what happens when we add milk to our tea. The chemistry becomes even more interesting as proteins interact with our extracted compounds.
Look at that. The color is changing to a beautiful creamy brown, and I bet it tastes smoother too. What's causing this change?
Perfect observation. Milk proteins, especially casein, bind with the tannins. This binding reduces the sharp, astringent taste and makes the chai smooth and mellow.
Now I understand. That's why tea with milk doesn't taste as sharp or bitter as black tea alone. The proteins are like tiny helpers making it smoother.
Now let's dive into masala chai. Each spice adds its own unique chemistry. Let's start with the most common ones and see what makes them special. Ginger contains gingerol, which gives it that characteristic pungent bite. But notice how boiling makes it milder. Heat changes the chemical structure.
That's fascinating. So when we boil ginger in chai, the heat actually transforms the sharp gingerol into something gentler? Chemistry is everywhere.
Exactly right, Arjun. Cardamom, cloves, and cinnamon are rich in essential oils. These volatile compounds give masala chai its incredible aroma and have antimicrobial properties too. Watch as heat releases these essential oils from the spices. You can see the aromatic molecules dispersing into our chai, creating that wonderful fragrance.
Professor, there's something magical about the smell of brewing tea that just makes me feel relaxed. Is there actual chemistry behind that feeling?
What a wonderful question, Sneha. Hot water and boiling release volatile aromatic compounds that travel through the air to our nose. These molecules trigger our olfactory receptors. Let's see the complete process. Water extracts tannins and caffeine, milk proteins bind with tannins, spices release essential oils, and volatile compounds create that perfect aroma.
This is incredible. I never realized that making a simple cup of tea involves so many fascinating chemical processes. Every sip is like a chemistry experiment.
Exactly. From polyphenol extraction to protein tannin binding, from gingerol transformation to volatile aromatics, every cup of chai is a beautiful symphony of chemistry. Science truly makes everything more fascinating.